So, in your own time, you can go over this if you're copying it down. Let me just do a recap of the basic graphs. Basic trigonometric graphs. The reason why I'm going over these basic trigonometric graphs is because they are the basis of everything that you are going to do in terms of sketching trigonometric graphs and also the interpretation. Okay, I'm going to start with y equal to sine x. So if I want to sketch y equal to sine x, it will look like this. Okay, so this will be the graph of y equal to sine x. Okay, obviously because you are in grade 11, it means I don't really need to do the table of values. I don't need to do a table of values because you are in grade 11. I can't teach you like amateurs.
But you said you were doing competition today.
Yes.
So we need to see everything.
No, there's no even though I'm doing revision, but I can't do it as if you've never seen this. Okay, so you see, if you were in grade 10, I want to do a table of values to go. I don't need to do that. You are in grade 11, we have done this before. Okay, we have got 1 there, we have got -1. Now, you see this 1 here, that's the maximum value, -1 is the minimum value. So, the coefficient of sine x there, okay, the a value is 1. The q is 0. So, that's the basic sine graph. Any sine graph that you are going to see later on from now on, or any sine graph that you have seen in the past, it comes from the one that I'm going to sketch now. So, when x is 0, generally here, let's use x, not theta. Okay. So when x is 0, y is 0. When x is 90 degrees, y is going to be 1. And when x is 180 degrees, y is going to be 180. So if you put x equal to 180 here, you get 0. If you put x equal to 90 there, you get 1. Okay, you've got your calculator, you should have your calculator in front of you. When x is 270, then you are going to have y be equal to -1. Okay? When x is 360, y is 0. So when you sketch the graph of y equal to sine x, it will look like this. Okay? That's the graph of y equal to sine x. Okay? Any graph of sine is going to come from, it's going to originate from this one. So we're going to play around with this graph of sine. Okay? Either we move it up or down. In grade 11, we can also move it to the left or to the right. We can even sketch it on the negative side of the x-axis. Last year, you were only sketching between 0 and 360 degrees. Right? In grade 11, we can sketch on the negative side, which is what we'll do probably from tomorrow. Sketch.
Yes, because let's say it goes past 360 or the other way, introduce the number.
I'm talking about the other side. Okay. You, in actual fact, it's unnecessary to use the reduction formula. because you need a table value. You need to know the exact values of x. Okay, so you can just use the negative values of the positives, and then you scale it on the other side. All right, so from here, I just want you to be aware that this distance here, let me use, you know this already, right? Hopefully. That distance there, that's the amplitude. Okay? The amplitude is the height of a crest. Okay? This shape here is called a crest. This shape here. It's called a crest. So the amplitude is also the height of a crest. It is also the depth of a trough. This is called a trough. Okay? So the height of a crest or the depth of a trough is called the amplitude. Right? Furthermore, you can also use the formula which I told you about. Amplitude is equal to y max minus y minimum all over 2. You can also determine the amplitude from the equation. Is the coefficient, it is the positive coefficient of sine x. So here the amplitude will be 1. The height of the crest is 1 unit. The depth of the trough is 1 unit. Then use this formula here. Your y max is 1. Your y minimum is negative 1. 1 minus minus 1 gives you a 2. Divide by 2, you get 1. Okay? So I'm telling you now that there are many ways of finding the amplitude. Okay? You can know all of them, or you can figure out whichever you want is the best for you and the easiest for you. Okay? So the amplitude for this graph here, its amplitude, okay, let me write it down at the bottom. So the amplitude of this graph is equal to 1. The period is equal to 360 degrees. Period refers to how long it takes for the graph to start repeating itself. Okay? So this graph here, this is one full cycle. After 360, it starts to repeat itself again. And then it carries on. So every 360 degrees, the graph of y equal to sine x repeats itself. Okay, but generally for you guys, last year you were only sketching between 0 and 360, but this graph can be sketched from minus infinity up to positive infinity. Okay, then let's move on to the domain. Okay, the domain, right? Our domain here is from 0 to 360. So we can just write it as x is an element from 0 degrees to 360 degrees. Right? I've used the interval notation there. Right? The range. Yes. Yeah.
On space side, it's available.
Here we are dealing degrees. It's not important to write x as a field of real numbers. Then for the range now, remember it's the set of all the y values. Right? So I can write that as y is an element. I'm starting from negative 1 up to 1. Then you have that. Right? It's not necessary to say y is an element of real numbers. Once you write that, we are including that. Okay? By putting the square bracket, we are talking about all the numbers between -1, including the -1 and positive 1, including that positive 1 as well. Right? So you are supposed to know these concepts here for every graph. Okay? Let's move on to the graph of cosine. Now, I'm not sure whether you know that the graph of cosine is actually the graph of sine. But it is the graph of sine if you move this graph by 90 degrees to your left. Okay? If you didn't know, you need to know that from now on. That's why in my case, when I teach the graphs of sine and cos, I teach them together, then the graph of time separately, because sine and cos are related. Okay? So, this graph, if you shift it by 90 degrees to the left, you get the graph of cos. Right? So let's sketch the graph of cos. Okay. So 180 degrees, then 270. You must use a ruler. Don't say Mr. Chipone is not using a ruler, so I don't need to use a ruler. You must use a ruler. In my case, my ruler is my eyes. So this will be 1, somewhere there will be -1. These are basic graphs, okay? That is the original graphs of sine and cos, one that I'm sketching. So if I'm going to plot, right, now this one here, when x is 0, y is 1. Okay, you can verify that with your calculator. Remember, our graph that we are talking about, it's y equal to cos x. When x is 90 degrees, cos 90 is 0. So we are going to have a point there. Then cos 180 degrees is -1. Cos 270 is 0. Cos 360 degrees, that will give me 1. Okay? Then, when I sketch it, remember when you're sketching with freehand, you have to practice how to sketch the graph. Right? You have to practice how to sketch the graph. Now this one, the amplitude, okay? Amplitude is the depth of that shaft, okay? You can also call it, it's also the distance from here to there. Let's just give the definition based on that shaft. So this is amplitude. Alright? Then, so our amplitude is also 1. The period is 360 degrees. The domain is the same as the one for sine. The range is the same as the one for sine. Remember, when you're writing range, domain, you start with the minimum. Okay? So you're supposed to know that. So this graph here is the one which we are going to play around with to get another graph of cosine. So whenever you get a question on the graph of cos, this must come into your head first. This one here. When you get a question on the graph of sine, the first one that I drew must come into your head first. Okay? So that's the one that you'll be playing around with. So we're going to play around with this graph. Move them up and down. Okay? That's grade 10. Then we'll move them to the left or to the right. And then we also compress them in grade 11, whereby we decrease the period from being 360 to say 180 degrees. So we can compress them. And I'll talk about that from tomorrow. Okay. Okay. We're supposed to have online local lessons. Because we are not coming to school every day. Maybe until the matrix finish their syllabus, which will be sometime maybe early September. Okay. That's when maybe we can request you to come to school every day after the matrix is finished. So now for maths, the students a long way to go. Right? So today when you go home, you refresh yourself with that, you memorize all this. Right, let me move on to the graph of time, the one which is more complex. Right, the graph of time. So number 3, y equal to tan x. Now this one is very unique because it has got asymptotes. It doesn't have an amplitude. Okay. Okay, so let's start with 180 degrees here, 270. Remember here I'm sketching them based on grade 10. Well, this is a revision of grade 10 work, right? Well, in terms of the values of y, I'm not going to worry myself about the values of y. Okay? But I can put, say, 1, if I put 1 tan 45 in 1, so it's somewhere there. If I put 1 there, and then I'll put -1 there. Right? Then, first thing, you must draw the asymptotes. The first asymptote is at 90 degrees because tan 90 is undefined. The second asymptote will be at 270.
So, isn't there a calculation method where you punch in the
Yes.
and you get even shows you the same result?
Yes.
Can you please teach us, maybe not today, but teach us?
I will. I will definitely do that. Don't worry. Don't worry. I will talk about that. So we have got this, right? So somewhere here we have got 45 degrees. So tan 45 is 1. So the graph will pass through somewhere there. I might need the y-intercept, so an x-intercept there, but I'm not going to worry about the x-intercept, right? And also here, we have got, if this is 45, then we have got 225, which will be somewhere there. So to pass somewhere at this point here. Okay. I know that you might be asking, what is he doing? So don't stress. I'm connecting my knowledge of special angles. Tan 45 is what? 1. So if x is 45 here, then it means the y value must be 1. Right? So I'll start from here. From the bottom here. The y-x is an asymptote. Or rather, it's not an asymptote, sorry. It's not an asymptote. So I'll start from here. Then I'll go like that. The y-x is not an asymptote, but -90, which is to the left of the y-x, is an asymptote. Because the period of a tan graph is 180 degrees. So the distance between any two asymptotes for this graph here, y equal to tan x, must be 180 degrees. The distance between any two asymptotes. Then, so this is not perfect. It looks something like that. Okay? Not perfect. I need to locate the correct y-intercept, but it should be there. And then for this one now, you see this one which is on top of the x-axis. For the fourth quadrant, I hope you are aware that we have got quadrants here too. Right? You see the first quadrant, y is positive, that's why the graph is starts from 0, it's above the x-axis. This is the second quadrant, tan is negative. Remember, second quadrant, tan is negative. Right? Remember that. This is the third quadrant. Tan is what? Positive. That's why the tail is above. Then in the fourth quadrant, it has to be down. So do that. Okay? So just to end the quadrant, to remind you, this is first quadrant, That's second, and then we put the third here, and then the fourth part. Okay? Then let's write down some very important properties. Amplitude is undefined. We can say no what? No amplitude. The period is 180 degrees. Domain. Okay, in this case, this one here is very unique. X cannot be 90 degrees and X cannot be 270 degrees. So we'll say X is between 0 degrees and 360 degrees. But X is not equal to 90 degrees because X is, if it's called 90, then we define if X is not equal to 270 degrees. So if you get a question asking you about the domain for the graph of tan, you have to mention that where there are asymptotes, the graph is undefined. Okay, we don't include those values. Yes. Because it goes down, you can't measure it. It goes down up to negative infinity, it goes up to positive infinity. For you, listen, for you to be able to determine the amplitude, you need to know what is the maximum value, what is the minimum value. For the graph of tan, you cannot know what's the minimum and what's the maximum. What? Whenever you get any graph of tan, if the question is asking you to determine its amplitude, the answer will be undefined. Stop stressing. The range, right? Now the range here, we are starting from minus infinity up to what? Positive infinity. So we can write as y is an element of real numbers, which means we are talking about all the values of y. Or you can say minus infinity is less than y is less than positive infinity. So you just write y is an element of real numbers. It covers everything. All right? Any questions? Okay, if you don't have a question, then let's move on to sketching. Now, since I've sketched the basic graph, let's start with the ones where the amplitude is no longer 1. Because all these graphs, except the graph of tan, that is sine and cos, their amplitude was 1. So let's start sketching the graph of sine or cos first. And I cannot. Now you need to take out your calculator because I'm going to bring the calculator here. Right, I just wanted to show you something. Right, because the use of a calculator is very important when you are sketching the graphs. You have to be a guru of your calculator. Okay, examples. Right, let's start by sketching the graph of. Now, I'm allowed to bring function notation. Right, so I can say, let's sketch f of x equal to 2 sine x. For now, I'm not going to bring the horizontal shifters yet. Let's start with one where the value of q is 0. So there is no shift. Okay? This 2 here, since it is positive, that's the amplitude. So if the question says determine the amplitude of this graph here, the answer will be what? A 2. If there was a minus 2 there, then you take the positive. Okay? Because amplitude is always positive. Okay. Yes, I'm emphasizing that because I've seen it during my teaching career. Learners writing a negative amplitude. That's incorrect. Amplitude is always positive. Right, let's bring our calculator now. Right. But before we bring the calculator, let me draw my Cartesian plane first, or my two x-axis. So I'll draw that one. Then the y for the x1. Okay, almost straight. Okay, we are going to sketch it because we are in grade 10 for now, though we are in grade 11. We just sketch it between 0 and 360 degrees. You are going to find that this graph will look like the graph of y equal to sine x. The only difference is that their amplitudes are not going to be the same. Alright? So I'll put 1 here and 2 there. Minus 1, minus 2. Now let's bring the calculator. I hope you've got your calculator with you. Right. Trig graphs are very important, by the way. When you write in a trig, there will be a question on trigonometric graphs, whether you like it or not. Right? And trig graphs are only taught in grade 10 and 11. They are not taught in metric. So this year will be your last time to learn about the graphs. Okay, so I hope that you've got your calculator in front of you. Right. So first thing, you go to mod, right? Go to mod. Now depending on your calculator, for me it will be number 7, table. I'll go to number 7, and it gives you that. It writes f of x. F of x is y, remember. So I'm going to put 2 sine x. So I'll put 2, then I'm sure you can see that there is x there, y there. So you press alpha. Okay, well, before I press that, I'll need to press sine first, then I'll press alpha x, then I'll close the bracket. So I have my function there. Alright? Are you following that? Okay, if you forgot, okay, that's how you do it. You have to know what I'm doing. Then you press equal. Now, my calculator now, because it's more advanced, it can do a table of values for 2 functions at the same time, which is what you are likely to encounter in grade what? 11 in metric. So we made us to sketch 2 graphs on the same system of axes. A calculator like this one will be better because you don't need to do it twice. Okay, so those blue calculators that you have and the gray ones like this, you need to take it to cash crusaders. Okay? Alright. Since I'm sketching one graph, I'll just have to press equals. I don't need, in fact, I don't have an equation for g of x, so I'll press 0. Then I'll press equals. Right? Where it says start, it's referring to the minimum value of x, which will be what? 0. So we are starting from x equal to 0. Alright? Then you press equals. Then when it says end, that's the maximum value of x, which will be, so that will be 360. Then you press equals. Then it says step. Now, by step, we are saying how many degrees are there between 0 degrees and 90 degrees, between 90 degrees and 180, 180 and 270, 270 and what? 360. How many degrees are there? What's the step from 0 to 90? It's 90 degrees. Okay? From 90 to 180, it's also 90 degrees. The step is constant. The step is what? Constant. So, you put 4 steps up, you put 90. Right. My calculator now, it will give me 3 columns. X, which is in degrees, f of x, that's the y value for f of x equal to 2 sine x. G of x, that's a second function which I don't have. So I put it as 0. So I don't need the third column. Are you following that? If I had 2 functions, then I would have some values there for g of x. We'll do such a case where I'll ask you to sketch 2 graphs on the same system of x's. Okay? So let's use column 1 and column 1, 2. So when x is 0, here, y is 0. Okay? And when x is 90, y is what? 2. I hope you can see it there. When x is 90, y is 2. So it will be somewhere there. When x is 180, y is 0. When x is 270, y is minus 2. And when x is 360, y is 0. Right? Then we join those points, freehand. Okay? We are doing it freehand. No ruler used. You don't sketch the graphs of sine, cosine, tan using a ruler. Okay? Yeah, both they are curves. So you don't use a ruler. If it's a curve, you don't use a what? A ruler. Freehand. Alright. Amplitude. Now your amplitude, allow me now to use a formula if you want. I can say y max, which is 2 minus 2. So this will be 2 minus 2 over 2, which will give me 4 over 2, which is 2. If you understood what I said earlier, that the amplitude is also the coefficient of that sine x, the positive coefficient, then the answer here will be a what? A 2. Right? Then the period of this graph is 360 degrees. After 360 degrees, the graph will start repeating itself. Right? The domain is x, the element from 0 degrees up to 360 degrees. The range,
So I have a question. If the graph started at negative 180 degrees and then finish at 180 degrees and then ask for the period, will the period still be 360?
yes.
The range is constant, sir.
No.
What?
The range is constant.
Then
The range is always the same.
it depends with the graph. It depends with the graph.
Like cosine is
Yeah. Don't confuse period and range.
the range is
Range is the set of the y values. Remember. So what's our minimum here? What's the minimum? Negative 2. So we start from negative 2. What's the maximum? 2. Okay. Remember, what I'm doing here is grade 10 work. Grade 11 work, that domain there is going to change. It won't start from 0. It can start from minus 180 degrees, it can start from minus 90 degrees, it can start from minus 360 and so on. But because we are still going over grade 10 work, which is sleeping, for the past 3 to 4 weeks we are sleeping. What is the what? That 2 there is the stretch. Okay. All right. It's a good question now. What